Virtualization and cloud are two incredibly important and common concepts in modern technology. Virtualization allows us to run multiple operating systems on one device and separate them across that device. On the other hand, the cloud allows us to connect to online resources, storage, and software such as Google Docs, Google Sheet, and Google Drive. In terms of what we're going to be covering in this video, we're going to be going over virtualization and cloud concepts, including what a virtual machine is, the two types of virtual machine hypervisors, so type 1 and type 2. We're going to be covering cloud service models like infrastructure as a service, platforms as a service, and software as a service. We'll be talking about guest operating systems or guest OSs. We'll be talking about cloud deployment models, so public, private, and hybrid. And then we're going to be ending off with cloud characteristics. Let's dive into what a virtual machine is. A virtual machine is a separate instance of an operating system or another form of a system that runs on a physical device. So you can have multiple virtual machines on one physical device. Virtual machines allow us to run multiple operating systems, servers, or applications. A virtual machine is great because it allows us to separate different instances of operating systems and to easily test software. Most of the times in a corporate setting for cybersecurity, virtual machines are used to see how a specific file actually functions. So for example, if we're looking at a file and we think it might be a virus, we could run it through a virtual machine and segment that virtual machine so that file can't infect the rest of our network or our computers. Now, there are cases where files can jump out of a virtual machine, but those are pretty rare and they're not common at all. A virtual machine also is useful too if you're running servers, because for example, you can have one computer or one server, and that one server or computer can then host multiple different operating systems, multiple different systems, and multiple different actual servers on one physical piece of hardware. So it's incredibly useful for that side of things from a business standpoint. Virtual machines also help us improve efficiency and resource usage. Many people use them in cloud computing and in IT and general corporate environments. And again, they also allow for safe testing and to isolate systems to ensure that security doesn't become at risk or violated if in the event a virtual machine opens an infected file. You could always just delete that virtual machine or spin up a new one. Next up is the different types of hypervisors that virtual machines are categorized as. And really there's two main ones. There's a type 1 hypervisor known as a bare metal hypervisor, and there's a type 2 hypervisor, which is considered a hosted hypervisor. So a type 1 or bare metal runs directly on hardware. Type 2 runs on an operating system. So the type 1 is a little bit more segmented, and the type 2 is ran through an actual operating system. Next up is type 1 tends to be faster, type 2 tends to be slower. Type 1 is also more secure and stable, but type 2 is generally a little bit more easy to use. Lastly, type 1 is mainly used in larger servers and data centers, and type 2 can be used on a regular device. So one thing to note here, while virtual machines are common in corporate settings, you can actually download a virtual machine onto a laptop or a regular desktop computer. And then from there, you can install different types of operating systems. So I could create a virtual machine for say a virtual machine that I wanted to install Linux on and have a Linux virtual machine. I could have a Windows 7 virtual machine. I could have a Windows 8. It essentially allows you to access different operating systems directly from one device. And you can use it both in a corporate setting, in a real IT environment, or you could even just use it at home on your personal device. Next up, let's dive into cloud and cloud service models. So cloud is a way that we're able to connect to online resources, and these different types of models define how we're able to access different resources. So for example, infrastructure as a service provides some sort of technical infrastructure to us. It's known as IaaS. Platform as a service, or PaaS, provides us some sort of platform, usually for building out code or running certain applications. Then software as a service, which is by far the most common one, or SaaS, provides us some sort of software over the internet. Things like Google Docs, Google Sheets, really any software that you can access through the internet that you don't need to actually install something on your computer, that's a software as a service. So let's go into the different types of aspects and what they provide. So an infrastructure as a service, that provides virtual machines, storage, and networking. PaaS provides a platform to build and run applications and code. Software as a service, again, provides software over the internet. In terms of management, infrastructure as a service, the user or the end consumer or customer manages operating systems, applications, and data. There's a lot to manage. For platform as a service, the end user or customer would manage apps, while the actual provider would manage operating systems and hardware. For software as a service, there's no installation or maintenance required on the user's end. Everything is done on the back end by the actual provider. They're maintaining things and everything like that. The only thing users need to do is we just need to maintain whatever sort of files or rights or permissions that we have for that specific software. In terms of difficulty, infrastructure as a service is somewhat technical, but it offers the most control and flexibility. Platform as a service is somewhat technical for developers, but it's not nearly as easy as software as a service. Usually software as a service is very easy to use and to manage. Again, the only thing you really need to set up with software as a service usually is rights and permissions and things like that. For example, allowing view access, allowing edit access, and things of that nature. And obviously any sort of files or anything within the program that you would need to manage yourself. So some examples of infrastructure as a service would be AWS, EC2, and Microsoft Azure. Platform as a service, you could think Google App Engine or Heroku, and then software as a service, most commonly Google Docs, Microsoft 365 products, different types of software that you can find online. There's so many different types of software as a service nowadays. And one thing I wanted to mention, one of the pros to these is you don't have to host anything on a physical site. So for example, if you wanted to use any of these services, you wouldn't actually need to host any sort of hardware. That's one of the main benefits is the company that's providing these services or these cloud service models, they actually host whatever hardware that you need, and then you just access those resources. So for example, infrastructure as a service, they might give you 2 terabytes of data per month or 2 terabytes maximum of storage, but you don't need to have a computer sitting there in your own office or your own building that has 2 terabytes of data. You just log onto your computer, boom, you've got the data right then and there. So it takes away a lot of the hassle of having to have a ton of hardware. And it really, really makes things simple from a perspective of keeping things tidy and not having to host so many things in your physical area. One of the drawbacks, though, is these do cost usually monthly or yearly subscription fees, which means that you're constantly paying for these services. But over time, honestly, if you have the right deal and pricing structure in place for your specific needs, they're usually going to save you money anyway over having to actually host hardware and things like that. So again, just to recap, infrastructure as a service used for virtual machines, storage, and different types of infrastructure for IT needs. Platform as a service, mainly for app development, coding, things like that. And then software as a service is used for actual software. Next, in terms of cloud, we have different cloud deployment models, including public, private, and hybrid. These deployments describe where cloud resources are hosted and who might have access to them. They also define how cloud infrastructure is set up, managed, and shared between various organizations, users, and customers. First, let's cover public cloud. Usually, public cloud is owned and managed by a third-party provider or vendor. Multiple resources are shared across multiple users, multiple different companies as well. That means that resources are shared even among multiple different customers and companies. In addition, public cloud is usually the lowest cost and it has the highest scalability. This includes AWS, Azure, and Google Cloud. One thing with the public cloud to note is though, even though it's the public cloud, it doesn't necessarily mean that everyone's able to access everyone's data. There's still some security here, but it's often the lowest cost and one of the easiest to use. Private cloud is a form of the cloud used only by one organization. So there's a clear separation, there's clear boundaries. It's only simply used and created for one organization. It's also usually a bit more secure than a public cloud because it's only being used by one organization. There aren't really any possibilities of data accidentally being shared. Additionally, it is a much higher cost than a public cloud system or a public cloud use just because you're getting your own private cloud solution. It's usually used by businesses that have very strict data needs. Following that is a hybrid cloud. It's a hybrid between public and private. So it allows data and apps to move between both the public and the private cloud. It's relatively flexible and scalable, and it's common in most modern businesses to use this version of the hybrid cloud. It's usually a good balance between public and private as far as data, security, and pricing goes. Finally, in terms of cloud characteristics, we have two main characteristics that we need to take into account with the cloud. First is in terms of scalability. This is a term used to describe the cloud. This is when resources can be increased or decreased on demand and as needed. It helps with handling high or low demand easily because when there's a high demand, then resources can scale up to meet that demand. When there's a lower demand, well, resources can scale down to meet that demand. Usually with scalable cloud, you can save money because you're only using what's needed. For example, if you have a website and you get 10,000 visits on a Black Friday sale, well, your cost is going to be higher during that day on a scalable model. But if you have, let's say, a lower day where people don't visit, let's just say sometime in February, no one's really doing much shopping, it's a slow time, maybe it's 12 to 3 in the morning, you would probably pay a lot less because you wouldn't be using as much resources because of the lower demand or the lower amount of visitors. Now, on demand is another cloud characteristic or quality. This is when services are available instantly when needed. There's no need to buy or set up hardware, and people pay only for what they use. So, in terms of scalability, we talk about things being able to be moved up and down as needed to actually address whatever need is there. And then on demand just means that it's available whenever it's needed. So in this video, we covered both virtualization and the cloud. These are two common technology concepts that you need to know. Neither of them are very difficult to understand, but they're incredibly important, especially in information technology and when you start to work in a corporate or a business environment.